All right, we are back for another one. Over the next few videos, we are going to be seeing how we can turn a simple Scala trait into a full-blown HTTP server and HTTP client using macros. If you've used something like Tapier or ZOHTTP, you're probably familiar with something like this, where we can use these composable slash operators to build up an endpoint spec, and then we can turn that endpoint spec into an HTTP client, or if we create an implementation of it, we can create a server. I've personally found this very annoying because you end up having a lot of boilerplate and making sure you need to have all the implementations in the server and have all the routes, and it just ends up being very cumbersome. And I tried to create my own version of this that also just ended up being cumbersome. So we're just going to go full-blown macros and try and make it so that if we can define an implementation of this trait, we should be able to turn that into an HTTP server. And if we can, well, we don't even need to implement it. We should be able to, using macros, derive an implementation of this trait, which will use HTTP to encode our parameters, send them over HTTP, receive a response, decode the response, and turn it into just our actual response that's here. We're going to have some kind of dumb, simple stuff going on just to start, of like the only thing we can do is task of string here. But it'll get progressively more and more complicated, and we're going to do progressively more and more parsing and implicits and all that fun stuff. So we're going to really be getting into the weeds on this one. I feel bad because in the last video, I said we were going to get into the weeds, and then our helpers ended up doing almost all the work for us. So this time we're going to be really getting into the weeds. All right, let's get down to it. So we've got just this simple specification for an HTTP request, HTTP response. What else here? We've got these path decoders. So here you can code a path and it returns your type and the remaining things it hasn't parsed. And here you could parse like query params and headers. We'll get to body eventually, but for now, all we're going to be trying to parse is what we've got going on here. Either something is a query or a URL. And yeah, all right. So what do we got to do here? This is our specification for an endpoint where you receive a request and then it returns an option of task of a responsive string. And so if this is none, that means it's like the wrong method or it's the wrong URL. It couldn't parse the URL. And this is the rest of the stuff. So, okay. Let's see. All right. This is what we need. Okay. Whew. So this, we're going to need to have a implementation for our macro. Okay. And then here we have to actually call our macro. And then here we can, in the macro, return a awesome. So that's compiling, and we can see what our little thing is going to run here in our temp main sort of thing going on, where we try and call all these different routes. And here's the kind of simple user impl that we made. So we've implemented user API, and we have this ref of users, and we use that ref and do stuff and create things and return it. And you can see right now, all of our things are returning a 404 not found. So we're going to have to do something about that. Let's get the compiler running. Okay. So these are the abstractions I've started to pull out. Is I've created this API, which this is going to represent like the trait level. We have a route, which is going to represent the def level. And we have this param, which is going to be our actual params. So that's like, go here. This is going to be an API. This whole thing is going to be a route. And then these are our parameters. Okay? Our goal today is going to be just parsing. And we're going to try and parse one of these API objects. Okay? So to do that, we're going to go here. We're just going to go that, and go val API. Equals generic.api derived a, and then we will just do here and abort API.toString. How we look? Okay, stuff's missing. Not surprising. We go here. Cool. Okay, so let's start by just doing that. Okay, so now we can see that we're trying to derive this user API. Awesome. Okay, so here we can get the type repr, like we just did, type repr of a, and then we should be able to get the symbol of this. So we're getting down into the weeds immediately. Symbols are unique identifiers that represent anything. It can represent whole classes, individual parameters. They can be a lot of different things. Maybe that's not the best explanation, but that's all I got. Okay, so we're going to do the type symbol of this thing. And let's go ahead and print out this symbol and see what we get when we print out the symbol. Okay, we're seeing we got the server user API. So that's what we got so far. Let's instead, we should have flags here. Let's see our flags. So got flags no init and flags trait. So we're going to assert that our thing must be a trait. This is the first thing we can do. So if not flags dot trait sim must okay. Let's see what we got there. And what if we go into our user API and we just go like abstract class API must be a trait. Awesome. Okay. So we can see how we can assert that we're working with the right kinds of things here. Right, where are we at? Here we are. All right, what's next? So we see that it must be a trait. And so tree equals sim dot tree. So as long as we have a symbol, we can get the tree of that symbol. It might return or throw. These sort of things are not generally like super well typed. There's a lot of just this within the compiler as well, of if you try and call something that's not, like if you try and do like sim dot companion class or declared fields, like all these different things, it's just gonna throw. If you try and call like get declared fields on something that's like doesn't have fields, it's just gonna die. So there's definitely like only a subset. If you like, that's why we're doing these sort of validations to give nice errors of like it must be a trait, because then we have an expectation that the functions we're calling later should be returning correct results. Okay, so what do we got? We got the tree, so let's actually print this tree. So tree show ANSI code. What do we got now? All right, we can see that we got stuff going on here. We're seeing our trait. We've got all of these things going on, and so let's continue to parse further. All right, so let's print tree dot show structure instead. We can see that we have this class def. Okay, and so the class def, we want to get, we know that we can filter this down to a class def. So tree.narrow class. This is just a little helper that will try and narrow our tree, and if not, we're just going to throw an error. And so now we can do class def dot, let's see. Should have some sort of body, parents, self, yes, body. Okay, so body dot what does that give us? All right, now we can see that we're down to our defs here. Okay, and so what we can do is these are called def. And so what we do is class def body map narrow to a def. Let's say body contains non. You make these a lot better as far as user messages, but that should be good for now. That for now. Okay, and so now if I go in here and I go like boom, it's going to say not a def. Awesome, and it shows us not the best location. At least tells us what this is here. Okay, so what next? Get this back to good. Now we need to parse this def. So let's create ourselves a little nice helper here. Actually, let's go in here. Let's go parse def. Return a route. We're going to need Scala quoted. Okay. And then this will be val routes is a list to a contiguous of route is route dot parse. Not gonna like us. Okay. And then here we should be able to return actually just an API. We have our type rubber, we have our sim, and we have our routes. Awesome. That's expected. Cool. So now we're down to the route level. Okay, let's go back here. All right, so the first thing we care about is the params. So we're going to want a param clause or a term param clause, okay? And this is going to be def term params we're going to force it so that you can only have one param clause. So here we're going to return this. Otherwise, we're going to port error and abort expected single param clause. Okay, it's getting past that, but if we go like this, API, oops, this needs to be here. Expected single term param clause. Okay, and these errors could all be admitted in better areas, and that's something we can definitely clean up at some point. But we're just trying to get to the meat and potatoes here, of figuring out how this stuff is working. So at this point, we've been able to parse our term param clause and what's in a term param clause. So it can figure out if this is an implicit, is it implicit or given, and so forth. Okay. And we've got our params, which is a list of valdefs. Okay. So let's kind of go and just print these out and see what we can find here. Right, here we are. We can go, okay, what's that giving us? Param, it says we have an ID, and we can tell that it's a long. Okay, so we're making progress here. Let's see. What was that? Okay, so we know that we have our valdefs, so we can do, can be a list valdef, and that's just params.params. Okay. Okay, and so here we just do that, should still be working here. Awesome. Now what? Let's go look at param. Okay, so we have a lot of stuff going on with params here. So we have this path, which can either be a const path or a non-const path. And then for a non-path, all we have at the moment is a query param. And we expect this expression of single param decoder. And here we expect to have this expression of path decoder. And here we have this decoder, which is coming from just the const path that we have here. Okay, so what does that look like? We're going to need to parse this. We have this route thing going on. And so let's figure out how we're going to parse this. So we're going to need to come here and we're going to need to have a given from expr of, oh boy, what was that called? Annotations. Here. Okay, so let's go like this. And all this stuff. So we need a from expression of this route. Okay. Okay. And what is this going to look like? New route get is going to return, what is this, new route get and just our URL. That's going to let us go. Cool. Okay, so we need to just do all of these guys. Still like us? Yep. And I think we're going to have to probably do something like that because it gives you issues otherwise. And just in case, we're going to actually come up here as well. Okay, cool. So we should be able to now get the route from the header. So let's see if we can do that. So do equals what? This should be def dot, oh boy, tree. This is a tree, so we should where do we have annotations? Don't have annotations. Okay, so I guess we're going to have to go to the symbol of this def maybe. Required of value. So this is going to require that from expression that we have going on up here. Route. And then we'll do port myroute.url. Awesome. So it's figured out here that we've parsed our URL, and so we're making progress. Have a list string is going to be okay. So you can see here, now we've got all of our parts. So this little symbol is supposed to be how we're gonna let's talk about that. So you can see here that this has no params and this has one. These are going to associate with the param.url down here. So we're going to need to make sure that we have like the same number of those, etc. All right, had to go back to the drawing board a little bit here because this gets a little complex. So I've beefed up our by ID here so that we have 2 path parameters and 2 query parameters, and I've intentionally kind of interspersed them so they're not in the same order. And so if you were to write this by hand, it would look like parsing these constant strings and then a path and then a constant string and then a path again. And then from there, we have the query parameters. And you notice that this path parameter kind of gets moved to the front because we care most about like parsing the path first and then all of the other stuff. And so you can, if you map this out, you have these const path and non-const paths at the start where all of these parse indexes are in order, and you notice the parameter index goes 0, 2, 1, 3. So not in order. So this is what we're going to try and parse here from our parameters. You can see here that you get a bunch of units, and then you kind of get ID, P2, P1, P3 here, and then we need to resort those back into ID, P1, P2, P3 so that we can call the function with the parameters in the correct order. All right, let's look at how we're going to do that. So here I've created this temp param, which is either a path or a query param, and we're going to cross-reference this with our parsed URL list here and try and build these guys, the full-blown ones that have both a parse index and for params we have the parameter index as well, so that we can order them by the way that we want to parse them, and then once we've parsed them, we can filter them down to things that we actually care about parsing out. We want to parse out all those constant units, and we then reorder those filtered parameters into the order that they actually are expected in the function. So lots of fun stuff to do. Let's see. So, okay, we got this. So let's go. We're going to get, let's call this paths, and this is going to be contiguous. We'll do int and option string. This can be there we go. Okay, so it's going to be, if we have a percent sign, we want that. And if we don't have a percent sign, then we want something like this. How's that looking? Okay, cool. So here we have that, and then have this contiguous of what our temp param. Okay, here's where it gets fun. So what is this? This is going to be our val defs. I'm going to zip with index. And here we have the val def and the index. Okay. What are we going to do? We're going to need to look for one of these here, a param. And so we're going to need to define a from expression for that as well. So let's go. Jeez. So many files to deal with. Okay. So we're going to go up here and we're going to do given from expr of param. Okay. Well, this will be this param.url, param.query, new query. Just to cover our bases, we're going to do something like that. And so what we need to do now is we need to find the equals. It's going to be valdef symbol annotation, and we're going to do required of value param. All right, what does that do? Okay, cool. So we're able to parse our parameter. That's cool. So what we're going to do with that is now we're going to match. Hopefully we can do that. So my param match. Cool. Don't actually care about it. And so what to do. Okay, so if it's a URL, we're going to try and find a URL decoder. So expr of path decoder here equals. All right, expert.summon. Okay, so we are going to need to have a type. So the type repr of our valdef is going to be like that. So here we have the type repr, and then we can do type of. Okay, so now we have the ability to turn this type repr into representing this fake type A so that we can reference it later. And technically this is actually going to be a path decoder of A. And so we're going to try and summon a path decoder of A, and when we reference this A, we're trying to summon the A from our valdef. And we're going to need to do no we can improve all these errors at some point, but for now, we not found path decoder of. So here's our decoder, and then what we should do is here we have a temp param path, we have our valdef, we have our parameter index, which is I, and we have our decoder. Okay, awesome. So we don't have a path decoder of long. Why not? We don't have any givens in here, that's why. Now we need to do the same thing here. So single param decoder, boom, boom, query param, not found, single param decoder string. Awesome. So we made it through that whole parsing process. So let's see. Back here. And now I guess what we can do is let's here and abort. We can do paths.makeString, new line here. And then we can do temp params.makeString as well. And now we should be able to see all the fun stuff we parsed. Okay. So we can see that we have API user P2 stuff, and then these question or the percent signs that we had, and then here we have URL query, and these have different indexes. Let's see, this is 0, 2, which if we go back over here, that's what we wanted. We wanted to have 0, 2, 1, 3. So now we have accomplished that. So we've gotten our params and the paths here, and now we need to find a way to zip them. Okay, so here we'll have param.path, and Then we have, that's going to be temp params.collect. That. And we have temp nom-paths. Okay. Whew. And then we need to figure out how many of these guys we have that are num int, and that's what? That's going to be paths count. Okay. 2.isEmpty, right? And then if num parsed paths does not equal temp paths.length, right? Do that, and we get that error. And then if we do this number, we get that the numbers do not match. Awesome. Oops. Okay, so at that point we can do just kind of dumb index lookups, and we know that we're not going to get some sort of index out of bounds. Okay, so now what we need to do is we actually get to zip these things up. So this is going to be this actual param here, param.path. And the way we can do this now is we can do which one? It's paths.map. Some const. This. And okay. We need more information, because we need to know not the actual index here, but we need to know like the index of which none index it is. So how to do that? Right? We'll do something like this. So probably not the best way to do it, but we're going on the fly here, and we can always optimize later. Okay, so what we're going to do is paths.collect none, and this is going to be just I. So now we should have a contiguous of int. Yep. And then we can zip this with index, and then that should just go to map. Okay. And then this would be index map.size. And then we should be able to go something like temp path is going to be a temp param.path, and that should be equal to temp path at index map I. Okay, and here this should be param.const path, and parsed index is I here, and path is our const string. And then here we'd have param dot non-const path. Okay, and then this is going to be, we have our valdef, we have parsed index is I, we have param index, which we get from this, and then we also get our decoder. Okay, that should be compiling again. Awesome. And let's see from this what we get. We should do let's just do this, and we'll see how bad that output is to look at. Okay, so we can see we have our const path, non-const path. We have 2, 0, which over here 2, 0. Then we have another const path, 3. Oops, I didn't fix that earlier. 3. Then a non-const path, which is 4, 2. 4, 2, amazing. Const path 5, stuff. Awesome. So we have successfully done this here. And now what we can do is we can... what are we going to do? So... Jesus, I got lost. There we go. So here we're going to need... There's stuff I added on the other function, which actually needs to go here, and I go and delete it. But okay, so we're going to want to put these non-path. These should all have this, and then the ordering for this should be equals key. So we want to put these first in the order of like the type. So we want like query params, then headers, then or maybe we do headers first, but it'll be easy. We just change those indexes, and it's going to automatically sort and resort things. Otherwise, by param index. Okay. Whew. All right. So, are we compiling again here? Let's see. All right. Cool. And so now what we need to do is we need to do the other part here. So we need to do our temp non-paths. So val real non-path params, say contiguous of param.nonpath. Okay? And so now we're going to need to do this non-paths.zip with index from start index is going to be 0. So we're going to want to do like this guy dot length is my guess, and we'll go from there. Map non-path and then this. Okay. And then what we got to do something like this here. We'll do it like that. Okay. And then we're going to do param.queryParam. We need our valdef. Got it right there. Need our param index. It's going to be this. Then we got our parse index. Then we have our param index. And then we have our nice decoder. So are we doing awesome? And then real non-path params. Cool. And then we get our valdef 6173. Awesome. So we've got all of those things. And then I think that's kind of coming down to the wire here. Oops. Okay, so we have our def from the parameter. We have real path params and real non-path params. Get rid of our annotation here. Awesome. So there's all of the trees. This is the trees under the hood. Yeah, so we can see that you've successfully parsed it. I'll be right back. I'm gonna print this out in a much prettier fashion. All right, here we go. So now we've parsed our entire API because we can parse one function, so we can parse all of them. That's the whole nice thing with macros. You write the parser, and then it just works for anything that fits what your macro is trying to parse. So here we can see we have our by ID, which let's see if we can go some sort of side by side here. Okay. So we have, there we go. So we have 0 API, 1 user, 2 0 ID, 2 0 ID, 3 P2, 3 P2, 4 2, 5 or 5, 5. Yeah, here 5, 6 1, 6 1, 7 3. Awesome. And then we can see if we filter out all of these const paths to only things that actually are going to get passed to the function, and then resort them based on the parameter index instead of the parse index, we can see that now these are in order and these are out of order, and we have our P1, P2, P3. So that's it for parsing. So in the next video, we will be seeing how we can actually take these parsed parameters and turn that into something that's going to be what? We're gonna essentially be creating one of these endpoints. How we can take these parsed parameters and use it to make a function that will parse an HTTP request into this option of task of HTTP response. So thanks for following along, and I'll see you in the next one.